of a light inextensible string of length 0.8 meters is attached to a fixed point. The other end of the string is attached to a particle P of mass 3 kilograms. Initially P hangs at rest with the string vertical. The particle P is then projected horizontally with a speed 5 meters a second, so it starts to describe a vertical circle. When the string is inclined at an angle theta to the downwards vertical, P has speed v meters a second, and the tension of the string is T newtons. Find in terms of theta an expression for v squared. Let's get a diagram drawn for this, and draw quite a big diagram just to give us some space. Here's my particle, mass 3g acting downwards. Just going to state this as our potential energy equal to 0 at this level. It's projected with u equals 5 meters a second. So then we're going to have this other particle. And what I'm going to draw for this other particle, because we're going to have to look at this in a moment, is a little bit of a crosshair to help us resolve some things. So here's my other particle. V is perpendicular to the string. The tension will be acting back up the string. The length of the string is 0.8. Mass acting down is still 3g. Now what we want to do is, this angle here is theta, so that means this angle here will be theta, and this angle down here will also be theta. These two angles across, I mean, if we keep on dividing we can do them, but these are the angles which are going to be key later on. Now this length here of our triangle, cos theta equals this length divided by 0.8, so 0.8 times cos theta represents this side of our right angle triangle. So that means the remaining length along the bottom here will be 0.8 minus 0.8 cos theta. Okay, so at the start, looking at the energy considerations, because of course vertical motion in a circle is done in terms of energy considerations. Potential energy is 0. Kinetic energy is equal to 1/2 times 3 times v squared, so times v 5 squared, which gives us 37.5 joules. In motion, kinetic energy will be 1/2 times mass, which is 3, times v squared, which is all I can do. So all I can do is write this as 3/2 v squared at this point in time. Now the potential energy is used using this H equals. So potential energy equals mass times gravity times height, which will come out as 3g. I'll just use g for the time being for the gravity times the height, which is 0.8 minus 0.8 cos theta. And I'm just going to leave it like that for the time being. So then, using conservation of energy, we can actually get an equation for this by saying, okay, 3/2v squared plus the 3g times 0.8 minus 0.8 cos theta is equal to 37.5. Okay, so I've balanced the equations and the energy considerations at this point. Now, if I times the equation both sides by 2 and divide by 3 so that I can isolate the v squared on its own, what we're going to get is we're just going to get v squared. Divide the g here by 3 and double all of these things here and expand the brackets. We're going to get plus 1.6g minus 1.6g cos theta. That's the left hand side done. Then doubling 37.5 gives me 75. Dividing it by 3 gives me 25. Now what I want to do is I want to subtract the 1.6g from both sides. and I want to add the 1.6g cos theta to both sides. So we get an expression for v squared given as 25 minus 1.6g will give me 9.32 plus 1.6g, which is 15.68 cos theta. So I've now got an expression for v squared. Part 2 asks for an expression for t. So I'm going to resolve for t. Resolving in the direction of t, the only force acting on it is this 3g, so I get t minus 3g cos theta. So using Newton's second law, remember we're going to get t minus 3g cos theta. That comes from resolving in the direction of t, and we've got 3g, and it have to find a component in the direction, opposite direction to t there. This is going to be equal to mass times acceleration. So mass, which is 3, and acceleration, if you remember, a equals v squared over r. So I'm going to get 3v squared over 0.8. Now if I add the 3g cos theta to both sides, I can get an expression for t. T is 3 divided by 0.8 is 3.75 v squared plus 3g, which is 29.6, 29.6, sorry, 29.4 cos theta. And so at this point what I want to do is link the tension with the velocity, so I'm going to substitute in the v squared, so I get t equals 3.75 times 9.32 plus 15.68 cos theta plus 29.4 cos theta. And so when I expand this bracket out, what we get as an answer is 34.95 plus 3.75 times the 15.68 plus the 29.4 gives me 88.2 cos theta. Okay, so that's part 2, having found an expression for the tension. Let's have a look at how the marks are awarded up until this point. So looking at the marks, initially there is, if we get the kinetic energy, and so if we get the kinetic energies we get an answer mark, and if we get the potential energy we get an answer mark. Then there is a method mark for using the conservation of energy. Turning over, if we get this expression for v squared, there is an answer mark available. Moving on to the second part, if we resolve in the direction of the tension, we get a method mark. There is then an accuracy mark if the correct values are substituted into that expression. Then there is another method mark if we substitute v squared into that tension. And finally, an answer mark for the correct answer only for this expression for tension. Now, part B says to find the greatest value of theta. Let's go to part B, sorry. It says to find the greatest possible value for theta and describe the subsequent motion of P. Okay, so what we know is the highest value of theta will occur when t equals 0, because the tension will be equal to 0. So we get 34.95 plus 88.2 cos theta equals 0. So rearranging, if I subtract 34.95 and divide by 88.2, we get cos theta equals minus 34.95 over 88.2. I'd leave this like this personally. take inverse cos of both sides so that we can get theta equals 113.34 degrees. Now, it says to describe the subsequent motion, well, as soon as the tension becomes zero, circular motion is stopped, because what will happen is the particles still keep moving, but it won't be in the path of a circle, and then the particle is essentially a projectile because it is under the action of gravity only. And I would be tempted and will mention that it is a projectile at this point, because a projectile is subject or under the action of gravity only. Okay, so let's just quickly check to see how we get the marks for this final question. So first of all, we get a method mark if you set the equation for tension equal to 0. Get an accuracy mark if you find the angle is 113.34 degrees, and you get an explanation mark if you explain what happens to that particle after this point. Okay, I hope that all made sense and that you understood that question.